Welcome to our first video in the series regarding planetary motion, in which we look at the ways that the different objects of the solar system move with respect to each other. And in this first video, we're going to be looking at orbits and various natural phenomena on Earth that are caused and explained by the orbit of objects within the solar system. So orbits occur because of a difference in the gravity between different objects within the solar system. So as the largest object in the solar system, we know that the sun exerts a very strong gravitational pull on not just the planets, but also the asteroids within the asteroid belt, which causes these to move around the sun in patterns that we call orbits. So orbit is both a verb, planets orbit the sun, and also a noun referring to the pathway taken as planets move around the sun. And as we look at the motion of planets, these orbits are naturally what we call planetary orbits, although as we'll see, different type of orbits are also possible. Now, the first thing that you'll notice in this particular diagram is that the orbits are not actually circular as they are usually depicted. You can see that the planets form not quite a circular shape, but an oval shape, which is what we call an elliptical orbit. So the mathematical name for this type of ovular shape is what we call an ellipse, hence the word elliptical. Now, this means that a planet is not the same distance from the sun at all points in its orbit. So if we zoom here and look at the Earth's orbit, we can see that this distance here is closer to the sun than this distance here. And each of these has a different name. So the point at which a planet is closest to the sun is what we call the planet's aphelion. Helion is derived from the Greek word for sun, helios, so the aphelion is the point at which a planet is closest to the sun. Now, conversely, this location here, if Earth were here, this would be the planet's farthest point away from the sun, which is what we call its perihelion. And peri, again, is the word meaning around that we see in perimeter, which is why we refer to this location where the planet is farthest away from the sun. Now, as mentioned before, objects can orbit other objects in the solar system that are not the sun. So many planets have moons. We know that Earth has one moon, and the moon is an example of what we call a natural satellite. And the orbits that natural satellites form around their host planet are what we call lunar orbits. So the movement of the moon around the Earth is an example of a lunar orbit. Now, orbits, specifically the lunar orbit, can be used to explain many natural phenomena that occur on Earth, the first of which we can see taking place in this picture. We can see that this is the tide that explains this. So what exactly is tide? It's something that's difficult for us to observe without living close to the ocean. But as with the sun and the Earth, the moon has a gravitational pull on Earth. And even though the moon is not strong enough to influence the movement of the Earth, it is strong enough to move the water around Earth. So if the moon were positioned here, its gravitational pull would cause the water in Earth's oceans to move this way. And likewise, if the moon were here, its gravitational pull would cause the water in Earth's oceans to move this way. So tide is simply the movement of ocean water on Earth in response to the moon's gravitational effects on Earth. So this picture here represents something that we call high tide, where the water accumulates in a specific area. And high tide occurs when the sun's gravitational pull, remember that the sun exerts its gravity on Earth, which causes the Earth to move. When the sun's gravitational pull and the moon's gravitational pull are pulling in the same direction, whereas low tide occurs in this situation here when the moon is causing the Earth's water to move away from this location here. So again, high tide occurs when both lunar gravity, the gravity from the moon, and solar gravity cause the water to pull in the same direction, causing it to accumulate in a single location like this. Now, keeping with the theme of the moon, we can look at another natural phenomenon that is explained by the orbit of the moon, and that being what we call the phases of the moon, which is the percentage of the moon that we can see depending on the moon's position in its orbit around Earth. So if we remember that the sun is here in relation to Earth, that means that its sunlight is going to be shining in this direction here. And we can see here that the moon is positioned between the Earth and the sun like this, meaning that the moon is actually blocking sunlight from being able to hit Earth. So when the moon is doing this, that effectively means that no light from behind the moon is able to make it to Earth because the moon is actually blocking it, rendering the moon effectively invisible at nighttime. And this is what we call a new moon, which marks the beginning of one lunar lunar orbit rather, and the end of another. So if we follow the moon going this way, now we can see that the moon is not exactly blocking 100% of the sunlight that reaches Earth. And since the moon does not produce its own light source, it only absorbs the light from the sun and reflects it to Earth. Here we can see that some of the light that hits the moon will be able to make it to Earth, allowing us to see a small sliver of the moon like this. And this is what we call a waxing moon, because as the moon progresses in this part of its orbit, it appears to get bigger as more sunlight hits it and then is reflected to Earth. And by the time it reaches the quarter-way point of its orbit, this is the point where we would see half the moon, because sunlight here would be hitting the surface of the moon, but only on this visible half, which would then be reflected to Earth. By the time the moon makes it all the way to the other side of its orbit, this is where the moon reflects the most possible sunlight that it can reflect, because all of the sunlight that hits the moon here is going to bounce back and be reflected to Earth. And this is what we call a full moon. Finally, in the latter half of its orbit, this has the exact opposite happening. As the moon gets closer to its original position at the new moon, we call it a waning moon, where the moon appears to get smaller as less sunlight hits it and is therefore reflected back to Earth, causing the moon to appear to get smaller. Now, the final phenomenon we're going to look at regarding the orbits of the sun, the moon, and the Earth around each other is similar to the phases of the moon, only we're going to look at specific circumstances where the moon and Earth block each other from the sun. And these are really cool phenomenons that we call eclipses. So the first eclipse that we'll see happens when the moon passes in front of Earth. And because of this, and this happens during the daytime, we can see, because the moon is passing in front of the daylight side of Earth. Now, when this happens, all of the sunlight that hits the moon here is no longer able to get past to the surface of the Earth, resulting in the moon creating a shadow that blocks sunlight from being able to hit a part of the Earth. And this shadow here, we give the rather cool name of the umbra, which again is just the Latin word for shadow. And because here the moon is blocking the sun from having its light reach Earth, this is what we call a solar eclipse, pictured in this rather cool image here. Now, the opposite of a solar eclipse is here when the Earth is orbiting the sun, and when the Earth gets in the way of the sun being able to hit the moon like this. So here, when the moon is in this position, it would normally be a full moon, but when the Earth physically passes in between the pathway of sunlight from being able to hit the moon, it is now the Earth that is casting an umbra on the moon, resulting in this unusual coloring here. So this red that we see is the partial blocking of the sunlight from Earth, but eventually the moon will disappear at some point during the night as it passes through Earth's shadow, and this is what we call a lunar eclipse. In the next video, we're going to look at the rotation of planets and moons and objects within the solar system and the implications that this has in terms of natural phenomena we can observe on Earth.